Next, let's talk about plusMinusAverage. We can think of this node as an upgraded version of the add double linear we just discussed. Compared to add double linear, it can do a lot more. Similarly, here's the node itself. Under its operation mode, it has three options: sum, subtract, and average. We're already very familiar with sum. 3 plus 2 equals 5, 4 plus 7 equals 11. Subtract is the same idea. 3 minus 2 equals 1, 4 minus 7 equals -3. So what does average mean? It just means taking the average. For example, the average of 3 and 5 is 4, the average of 2 and 4 is 3. Depending on what we select, it can perform different calculations within this one node. Another difference is the input. It no longer only supports single value inputs. First, it has input 1D. This one is similar to the input 1 and input 2 types from add double linear. So we can directly connect a translate x value to it. But what's different is, it doesn't just support two input attributes like add double linear. Here, we can have infinitely many attributes put in. The way it's represented is input 1D0, input 1D1, input 1D2, and so on. So if we have 10 values we want to add together, we can choose to use plusMinusAverage. Next, it also has input 2D. What's the difference with input 2D? It's actually similar to the vector type attribute we talked about. What's different is it only has two sub-attributes, x and y, instead of x, y, z. The representation for each one is input 2dx and input 2dy. And for the specific input attribute representation, it would be input 2d0 dot input 2dx, input 2d0 dot input 2dy. And if we have 1, 2, 3, 4, we just change the index number in the front. It can also accept countless of these input attributes. And then there's input 3D. Input 3D is identical to the vector type we talked about. It has three attributes, x, y, and z. Input 3dx, input 3dy, and input 3dz. Similarly, it can also support infinite input attributes. Finally, depending on the input attribute type, it also has different output attributes. Here it has output 1D, output 2D, and output 3D. Three different output attribute types. Let's go back into Maya and see how it actually works. We can see I have three driver objects and one driven object in my scene. Let's select them, add them to the node editor, and create a plusMinusAverage node. We'll use translate x to connect them again. Here we can see it has input 1D and then 1D0, then 2D, 2D0, and after that 2dx and 2dy. 3D is the same, 3dxyz. Let's first use the 1D type, which is similar to translate x. And let's connect the second one. Now look, input 1D0 is gone. Why is that? We talked about this before. Because input 1D0 is already connected to other attributes, it no longer shows up in this menu. So we need to change the display mode to show it. Okay, here's input 1D1. Let's connect the translate x to it. We'll see input 1D2 automatically appears, connected as well. And finally, connect output 1D to the driven object's translate x. Let's look at this plusMinusAverage node. Let's switch to the attribute editor. Here we can see an operation. It has four operation modes. The first is no operation. The second is sum. The third is subtract. And the last is average. The default here is sum. With sum, as we see, each one has 100% control over it. And the final result is the three added together. If I change it to subtract, now look, if I move the first one, it moves along with the first one, but the next two will move in the opposite direction. Why? Because the order is 0 minus 1 minus 2. Our first one is 0, 1. Then 0, 2 and 0, 3 are both in subtract mode. So it's taking its translate x minus these two translate x. So when their value increases, the driven object will go in the opposite direction. For example, this x-axis moved 10 units. If my second driver object is 2 units, then it should be at 8 units. If I set 3 units here, it's the result of subtracting all 3 values. And if we change it to average, then it just takes the average of the 3. This way, as we see, each one has an average control over the final driven object. It's taking an average of the 3. Now let's look at input 2D and input 3D. Here it's really just a different number of attributes. Let's delete all this. And let's just connect translate directly to input 3D. Same thing here. And we can connect it directly over here. This way, the translation on all 3 axes is a sum result. Meaning x-axis are added, y-axis are added, z-axis are added, and they control the driven object's x, y, z axis respectively. But let's not assume it can only accept this vector attribute type. We can also control each one individually. For example, connect translate x to it. Then say use rotate y and connect it, and scale x and connect it. We can also control its individual attributes, just like we control translate. We can control the individual x, y, and z axes. For us here, it's just 3 attribute fields we can work with. Same logic for the output. Correspondingly, on this side, we can also, for example, just connect output 3dx to translate x, output 3dy to rotate x, and output 3dz to another attribute like visibility. Or we can connect it to other nodes. That's all possible. So that concludes our introduction to the plus-minus average node.